Hello, this is a getting started tutorial with Zoom USB audio converter with the possibility of very high sampling rate simultaneously on two channels. So in order to use it with our measurement FFT analyzer software, there are some points which have to be addressed. As first, we have to set the input gain of the Zoom device to the lowest sensitivity, or let's say to the highest unsensitivity. So in this case, after the installation of the Zoom software, we have to go here to the Zoom folder. And then we have to use these sliders so that they are set here for both channels to the value 0. So that's all. Next, we have to make sure that the highest sampling rate is adjusted. So in this case, we click on the taskbar to the loudspeaker symbol and open the sound settings. So here in case of the Zoom device, I set this is now the output settings, okay. And the input settings should be here also set to 192 kilohertz. So this is important. So for ultrasound measurements. So, okay. Now, next, the customer can use any available free software for measurements like ARTA software or the visual analyzer. In our case, I show you how to measure it with our NVH analyzer software for scientific and professional use. So now I start. Here's the NVH analyzer software. Here at the upper left corner we see the current version number of the NVH analyzer. Here I choose the 2-channel device, and here I choose the Zoom audio converter. So here for this test we use the acoustics, vibration and acoustics module. So now we have here the possibility to set the sampling rate 192 kilohertz, and at channel number 1 I have here the IEPE measurement microphone MI19. So in case of the Zoom device, the Zoom device have another range input is 5 volt. For this reason we have to pay this, we have to correct here this value. So I will I have already prepared here a setup. So in the electrical range input is here 2.434 volt for both channels. So now I can key in here the MI19 and here at the channel number 2 I have a hydrophone connected. So hydrophone. So the sensor sensitivity of the of the MI19 microphone is roughly 50 millivolt per Pascal. And the sensor sensitivity of the hydrophone is much lower. So it is 0.12345 So this is the sensitivity. So here we can go through as fast. So this is here the graph setting. Okay. So now I make it here a little bit shorter, smaller the display. And now I like to calibrate the measurement microphone. So my calibrator delivers 94 dB at 1000 Hertz. I have here the calibrator. And then I connect it like this. Then, so here now we get our signal. So it takes a while. So and then if the value is here settled, we can start the calibration. So now we see that the amplitude is still increasing a little bit due to the air pressure inside of the small cabin. So now we are at 49 millivolt. Now I will calibrate again. So and now we can see here that there's not much change anymore. So for the hydrophone we don't have a calibration device. For this reason we have to take the sensor sensitivity value from the hydrophone manufacturer. So this is here this value and this we just calibrated. Now we can save the setting. So we like to see now, or I like to define now a different graph. Let's say I want to measure on channel number 1 the time domain sound pressure level, so level with time. Let's say over from 0 to 100 to 180 seconds. So this is here from 0 to 120 dB. So at channel number 2, I like to see the FFT spectrum. So the FFT is from 0 to 95,000 Hertz. So this I will remove. And here is 10,000. So this is from 20 to 140 dB. And here the grid distance is 20 dB. So I activate here the auto scaling. Here on channel number 1, also the auto scaling. So on channel number 2, I will take over the same settings from graph to graph number 3. So that means I take over here the axis and the physical functions and copy the settings to graph 3. But this is now here channel number 2. And this settings from channel number 1, the FFT spectrum, and the settings copy to diagram 4. So, and this is channel number 2. So means here I have Y auto scale, here, here, and here. So this is now our graph, and now we can start with the measurement. Also, in the analysis window, we have to check, or in the FFT analyzer, we have to check here some settings. So means for the level with time measurement, we can say, okay, we want to have 10 values per second, and the maximum time span is 180 seconds. 80 seconds. So, and here we can take this averaging filtering or time weighting. So, okay. So if somebody need, for example, something like a level with time measurement over the whole day, so then he have to increase here this value to 84,600 seconds. this complete setting, it's possible to save all setups as a project. So now I save this. New project is Zoom Hydro, for example. So now I can start with the measurement. I can enable the sensor signal from calibrator. Now we see here the FFT is going up to 95 kilohertz. FFT is auto-scaled, and here at the left graphs we have our level burst time measurement. So here I knock to the hydrophone. So it's of course possible to record the raw data also. In this case I use a new file name and now I start with the raw data recording. So the calibrator is still running. We see here our 94 dB. Ah yeah, okay, I have to click here start. And now we see here our environmental noise. Of course, it's possible to change here the setting, for example, to averaged FFTs, so that we can see the ultrasound here in this case at about 38 kilohertz from the microphone. So this ultrasound is generated by the monitor or mini PC. So now I stop this measurement. If I click now here to this graph, I can open it in a new window and zoom in and zoom out, or if I hit the alternate and G for graph, I can export this data in CSV format. So now let's check. I just open, no, right mouse button. So here we can see the values still from the sound level calibrator, so close to 94 dB. So that's all for today. Thank you very much, and I wish you a pleasant day.